Good morning, students. Today we are going to discuss again few numericals from chapter 3, motion in a straight line. Now the first numerical which we are going to discuss is your this one. So let me go through the question. Two trains A and B of length 400 meter each are moving on two parallel tracks with a uniform speed of 72 km per hour in the same direction. Both are moving in the same direction. So relative velocity is nothing but the difference between the two velocity. So let me read out. With a uniform speed of 72 km per hour in the same direction with A ahead of B. So A is in advance and B is behind. So with A ahead of B. The driver of B decides to overtake A and accelerates 1 meter per second square. So you see two trains A and B. A is moving without acceleration. You can consider A equal to acceleration equal to 0 in case of train A. But train B, as it decides to overtake A, there is an acceleration A equal to 1 meter per second square. If after 50 seconds the guard of B just brushes past the driver of A, what was the original distance between them? So you see during 50 seconds train A moves without acceleration and train B moves with the acceleration 1 meter per second square. Okay, during 50 seconds, and after 50 seconds this happens. The guard of B just brushes past the driver of capital A. What was the original distance between them? So let me to repeat once again. Two trains A and B. A is moving without acceleration for 50 seconds and B moves with acceleration 1 meter per second square for 50 seconds. So for train A as 72 km per hour, so convert this one in meter per second. It is 20 meter per second, and as we are trying to define the parameter for t equal to 50 seconds or during 50 seconds, so t equal to 50 seconds, as no acceleration for A, uniform speed as per the question, that's why A equal to 0. So use this equation, S is equal to ut plus half at square. So A is 0, so second term goes off, so you do have S equal to 1000 meter. Now for train B, as we are trying to define the parameter during 50 seconds, so u equal to 72 km per hour, that is 20 meter per second. Acceleration is your 1 meter per second square, and t equal to 50 seconds again. So using this parameter, the distance is your 20 into 50 plus half into 1 into 50 square. So on simplification, 20 into 50 is your 1000, and this one is your 50 2500. 2500 is your 1250, so it's your 2250 meter. Now after 50 seconds this happens. The guard of B just brushes past the driver of A. What was the original distance between them? So during 50 seconds this happens. So if you have to define the distance after 50 seconds, so what you have to do, you have to subtract. So thus original distance between them is 2250 minus 1000, and it's your 1250. So please check it out. Now next sum which we are trying to define, this one. On a two-lane road, car A is traveling with a speed of 36 km per hour. Two cars B and C approach car A in opposite direction with a speed of 54 km per hour each. At a certain instant, when the distance AB is equal to AC, both being 1 km, then B decides to overtake A before C does. What minimum acceleration of car B is required to avoid an accident? So car A speed is here 36 km per hour as per the question. So it's here 10 meter per second. Car B is here 54 km per hour. So it's here 15 meter per second. And car C is also 54 km per hour. That's here 15 seconds. Now if you see this figure, A is moving with velocity VA and B and C approaches A in opposite direction. As per the question, on a two-lane road, car A is traveling with a speed of 36 km per hour. Two cars B and C approach car A in opposite direction with a speed of 54 km per hour each. Now what you have to do, you have to define the relative velocity or relative speed. So VA, VB, VC we know. So speed of B with respect to A, that is your VB minus VA. B and A both are moving in same direction. That's why minus, difference between two. And VCA both are moving in opposite direction. So it is the addition. So it's your 25 meter per second. Now as per the question, it says that at a certain instant when the distance AB is equal to AC, both being 1 km, then B decides to overtake A. Okay, B decides to overtake A before C does. So AC equal to 1000 meter and relative speed of C with respect to A is your 25 meter per second. So time required is your 40 seconds. Now in 40 seconds C overtake A. Now if B wants to overtake A before C does, the time should be 40 seconds. That's why we have written, to avoid accident, car B has to cover the same distance of 1000 km in 40 seconds. So if you use the equation S is equal to ut plus half it square, you will get the required acceleration for B. So 1000 S equal 1000 and U is your nothing but relative speed of relative velocity of B with respect to A, that is your 5 meter per second. That is your 5 into time is your 40, half A into 40 square. So on simplification, 1000 minus 200, that's your 800, that's your 800 A. So A equal to 1. So therefore A equal to 1 meter per second square. So the acceleration of car B must be 1 meter per second square. So these are two sums basically from the exercise. Now you go through all the sum and try to find out your difficulties, and you just specify which sum you need. That sum I will do. Otherwise, if I go for all the sum, it takes lots of time. Okay, so please go through and try to find out your difficulties. Probably from next class we are going to start a new chapter, but you try all the sum which is available in the exercise, and if there is any problem, if any sum you need, please specify and we will try to explain. So this is all about. Thank you.